right, this is 6.1, imaginary and complex numbers. So let's start out by looking at something that we already know, like the square root of 36. So we know when we have the square root of something, that means what number times itself gives you that number inside the square root. Okay, so for this case, what's the square root of 36? That would be 6 because 6 times 6 equals 36, right? But now, for the square root of negative 25, we have a negative inside our square root symbol. And this causes a problem, right? Because positive 5 wouldn't work because positive 5 times positive 5 is positive 25. And negative 25 wouldn't work, or sorry, negative 5 wouldn't work either because negative 5 times negative 5 is also positive 25. Okay? So for the longest time, when anybody came up with a negative inside a square root like this, they would just say, oh, this problem's not possible. They would write no solution, okay? And then many, many years ago, some Greek guy decided he would just invent a number for this, okay? And then years later from that, kind of as a way to mock that guy, another Greek math guy decided that he would call them imaginary numbers as a way to kind of like poke fun at him, like look at these imaginary numbers. All right. Then it wasn't until much later, even still, that another Greek math guy named Gauss started using them, and people started taking them a little bit more seriously. And then further, not until the 19th century do people start coming up some actual real world applications for this. Like we'll get into a little bit later. There's some applications with physics and some electrical currents. So we'll look into some of those later, but I just wanted to give you a little bit of the history on this. All right, so why did this cause a problem? We know that 5 times 5 doesn't work. We know that negative 5 times negative 5 doesn't work. So what we figured out, or what we kind of went with, is that 5i times 5i equals negative 25, okay? And so the key here is to recognize, well, we know that 5 times 5 is positive 5, but I times I equals negative 1, okay? And if we multiplied 25 times negative 1, that's how we get negative 25, okay? So this part here is really the key to imaginary numbers, all right? So that I times I equals negative 1. All right, so how about the square root of negative 50? All right, so this one's not going to work out as nicely because we don't have a number that multiplies by itself to equal 50. So what we're going to do is just call this I times the square root of positive 50, and then we're just going to simplify that radical. All right, so we know that the square root of 50 can be broken down into the square root of 25 times the square root of 2. All right, and the square root of 25 we know is 5. So that would be 5 times the square root of 2. But we don't like to write the I in the front. We're going to write this as 5i times the square root of 2. All right, and that's it. That's as far as we can go with that. All right, so now we're going to look at this a little bit more in depth. So I'm going to zoom in here. All right, so the first thing we got to recognize is that I is just I. All right, and as I mentioned before, I times I, or I squared, equals negative 1. All right, so now then we have I to the third power. Well, I to the third power is really just I squared times I, right? 1, 2, 3. Well, I squared we know is negative 1, and negative 1 times I would make this negative I. All right, and then I to the fourth is really I squared times I squared. Well, I squared is negative 1. I squared is negative 1, so this is negative 1 times negative 1, which a negative times a negative is a positive. So this equals positive 1. Okay? So now let's look at I to the fifth power. Well, I to the fifth you can think about as I squared times I squared times I. Well, I squared is negative 1. I squared is negative 1 times I. Well, negative 1 times negative 1, that's positive 1. Positive 1 times I is just positive I, right? Okay, and what about I to the 6th power? Well, I to the 6th, I'm going to erase this a little bit. I to the 6th, you can think about as I squared times I squared times I squared. All right, so that's -1 times -1 times -1. All right, -1 times -1 is +1. +1 times -1 is -1. All right, so what we're starting to recognize here is that this here keeps repeating. So what's going to happen is we're going to keep going from I, -1, -I, +1, and we start back over. I, -1, -I, +1. All right, so if you're looking for I to the 15th, right, well, we could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. There we go. So I to the 3rd, right? So this I to the 15th is going to be -I, right? So what's a faster way than just counting this out? Well, if we're going through 15 times, well, how many times are we going to go through this list of 4? So we're going to divide this by 4. 4 again goes in 3 times, right? And we have the remainder of 3. Okay, so the remainder is kind of key. So remainder of 3. So we have 1, 2, 3, and that's how we get I to the 3rd power. All right, how about I to the 34th? Well, let's see how many times does 4 go into 34. Looks like 8 times. 3 times 8, or sorry, 4 times 8 is 32 with a remainder of 2. So that means it goes through 8 cycles of 4, right? And then we have a remainder of 2. So that would leave us with 1, 2. I squared is -1. So I to the 34th power is going to equal -1. All right, what if we have something that goes in perfectly? How about like I to the 40th power? Well, 40 divided by 4 is 10. There's no remainder. That just means it's going to end perfectly at I to the 4th. So I to the 4th would equal, or I to the 40th, sorry, would equal +1. All right, now let's look at some equations where we might get some imaginary numbers as our answer. So for this first one, 18 is equal to -2n squared. First thing I want to do is get the n squared by itself, so I'm going to divide both sides by -2. And I'm left with -9 is equal to n squared. I want to get rid of this n squared, so I'm going to do the inverse operation of squaring, which is taking the square root. And if I do it to one side, I got to do it to the other side. So the square root of n squared is just going to be n. And the square root of -9 is going to equal plus or minus 3i. Okay, so we introduced the square root symbol here. So anytime we do that, we're going to be left with a positive or negative answer. So for the first example we looked at, it was just, we were finding the square root of +36. And so this is kind of just referring to the principal square root, which is just always going to be positive. But when we introduce the square root symbol into our equation, we need plus or minus. So this is definitely something we should pause the video and make note of. Let's go ahead and write this in your margin. When you introduce the square root symbol, your answer will be plus or minus, okay? So this would be plus 3i or negative 3i. All right, hopefully you got that written down. Let's move on to the next one. So we got x squared plus 1 is equal to -6. So I'm going to get that x squared by itself. So I'm going to subtract 1 on both sides. And I'm left with x squared is equal to -7. All right, now I want x by itself. I just want 1x. So I'm going to take the square root of x, take the square root of -7. Now I'm introducing the square root symbol, so I know I'm going to have a plus or minus as my answer. Square root of x squared is just x, and I'm going to be left with plus or minus. There isn't a number that works out nicely for the square root of 7, so we're just going to call this plus or minus I times the square root of +7. All right, Easy as that. Last one for today. How about we look at 3y squared minus 2 is equal to, let's go with negative 56. All right, so the first thing I want to do here is get rid of this negative 2. So I'm going to do so by adding 2 on both sides. All right, and I'll be left with 3y squared is equal to negative 54. All right, now I want to get this coefficient in front of y squared out of there, so I'm going to do so by dividing. So I'm left with y squared is equal to negative 54 divided by 3, which is negative 18. And now I'm going to take the square root on both sides. Square root of y squared is y. And now I introduce the square root, so I know I'm going to have a positive or a negative answer. And the square root of negative 18 is not going to work out nicely, so I'm just going to call this I times positive 18. But I can still simplify the square root of 18, so we still need to do that. The square root of 18 breaks down into the square root of 9 times the square root of 2. And the square root of 9 is 3. So we're left with, our final answer here would be y is equal to plus or minus. Remember, we don't want to call this I3. We're going to call this 3I times the square root of 2. So there's your final answer. And I want to show you just on your calculator, in case you are not very good at simplifying radicals. Just want to show you how to do that on your calculator, even if it's just checking your answer. So if we're at this point and we try to let our calculator go from here, we can pull up our radical by hitting the second key and the x squared button. Now, if you try putting in a negative here, your calculator's not going to like that. It's going to give you domain error as your answer. Okay, but if you take care of that negative by pulling out the I and calling this I times the square root of positive 18, your calculator can check that one out for you. So you put in positive 18 and press enter. There you go. It simplifies that for you. Okay, just remember when you're writing this out, you want to make sure it's the number times I and not I in front of the number. All right, so that's all I got for you guys today. Why don't you guys give practice problems 1 through 10 a shot, skip 11 through 18 for today, and then you can go on and also try 19 through 27. All right, good luck.